All right, so today we're going to be focusing on situations where we start with a graph. So we have some f of x graph here, and then saying how do we use that to make the graph of its derivative? And one of these graphs over here in this problem is the derivative of this original function. We're going to do a number of problems like this where we're just matching them, and then we're actually going to start building the derivatives ourselves from the original graph as well. So take a look here at this original function and start thinking through how would you figure out what the derivative looks like. All right, so a good strategy for doing these, one that I always use, is I always start by looking to see where is the derivative going to be 0. Now remember, derivative means the slope of the tangent line. So I'm basically looking to see where does this graph flatten out. And there I've drawn them in this case I see 3 of them, with those little red segments there. Because those are the 3 places here where our graph basically is flattening out. Our slope at those respective points would be 0. And so what that tells me is that when I go to graph the derivative more specifically, at those points, I should actually be at 0. So for instance, if I drop this down here, it looks like that's somewhere between -3 and 4, -3 and -4. So I know somewhere in here I should be hitting 0. So it looks like that's probably going to rule out graph A right there. Let's check the others as well here. So this one looks like it's around 2. So I should have a 0 around 2. Well, based on that alone, it looks like we can go ahead and conclude graph C is going to be our winner here. And we can confirm that. Notice that this last one here at 6, in the original, we saw that it flattened out at 6. And so again, I'm looking to see a graph where it goes through 0 around 6. And that alone is oftentimes one of the best and fastest ways to figure out where is the derivative going to be 0, and then which one is the derivative then. A couple other little clues that we can look for is you can also be looking to see where is the slope positive and where is the slope negative. Because for instance, in this graph, you'll notice that in f of x, between those 2 zeros, so on that section that I boxed out there, our slope is negative, notice. So that means that between those same numbers, as I take a look at my possible graphs over here, I should also be looking at negative numbers between there. And so that's why we're seeing that come up over here on graph C. You'll notice that between those 2 numbers, it is entirely negative. And that's basically what a sketch of that might look like, where it goes further down because it's getting kind of steeper in the middle, and then it slowly returns back to 0. It's not like it just jumps down into negatives and then jumps back, because today we're dealing with curves instead of just those linear piecewise types of functions. All right, so I've given you lots of hints. Now it's time to start putting some of those into action. We're going to do a number of these. So go ahead and take a look at this original function and try to pick out which one's its derivative. All right, so we're looking for the derivative in this case. So once again, I like to start out by looking to see, okay, where does it hit 0? And I can see that it looks like it's going to hit 0 just off the grid up here. So it's going to be somewhere up there. And then we have a 0 down here. And then we have a 0 over here. Which of our graphs of our possible derivatives over here on the right side shows a 0 at each of those 3 points? Well, notice that's one of them that's going to be between -4 and -5. One of them that's around 1. And notice I'm just looking to see where does it hit 0. So like where's it crossing the x-axis? And then the other one there, somewhere between 5 and 6. So which graph is it? Let's see. Yep. All right, next one. Take a look through this. And once again, in thinking about this graph, for this one, I'm just going to think through what if I were trying to sketch the graph myself. So the first thing I would do is I would still look to see, okay, where are the zeros going to be? And so I have these 3 zeros. And so if I'm graphing this, I know that those would be zeros in there. Now, that means that we basically have 1, 2, 3, 4 different sections to this graph. And what's the slope in each of those? So like to the left of our first one, so I'm looking over here. What's our slope on our graph here? Is it positive or negative? Negative. Okay, so I know I have a negative slope through there. In our next section, is our slope positive or negative? That would specifically be up through here. Notice it's going uphill, so yes, that is positive. Okay, in the next section, is our slope positive or negative? It is negative. And then in our last section, is it positive or negative? Positive. Because again, we're looking specifically just at the slopes in those areas. All right, so knowing that, that means I'm looking for a graph where I'm going to be, let's see here, actually let's set up a new axis here just so I can kind of draw out what it's going to look like, and then I can match it up. Just because I'm giving you a different way to look at it. So if I continue these down, so I'm kind of matching up, I should be in the negatives going to 0 to the left of it. And then between these next two lines, I should be in the positives and then returning back to 0 down here. So then I'm just going to kind of do an up loop there. Okay, in the next section, it's negatives before it gets back to 0 again. So actually I can do a little bit better aim than that. There we go. And then it's positive slope after that. Well, based on that, we can now look over to see which graph have we basically sketched. Looks like A to me. All right, so taking a look at this one, we again are trying to figure out, okay, you know, what's the graph going to look like? And so I'm looking to see where is my slope going to be 0. Okay, I definitely have those 2 points. So at negative 6-ish, I should have a 0. So that already means that we can rule out B because it doesn't have a 0 there around negative 6. So B is ruled out. Then at 0, I should have a 0 as well. And so, should have one there, should have one there. Okay, that looks like good possibilities. So then, how do I decide between those two if I just have that? Well, notice what's happening to the right of 0. So if I'm looking between here and the edge of the graph, what is the slope for that whole section? What's the slope in this box? It is negative slope. So our slope all the way down from this 0 down to this 0 is negative, which means that in my graph, I should be seeing a whole bunch of negative numbers down there. Notice C does not have that. C goes down to negative, but then it goes up into positives. And so ends up being that A is the winning number here, or the winning graph. But again, it's because throughout this little section, as we go down this graph between 0 and the edge of the graph, notice our slope is negative throughout that entire way. Now, at the start, it's not very negative. And by the time we get into the middle, it's much more negative. It's a steeper slope, a steeper negative slope. So that's why when we take a look at our graph over here of our derivative, which is really the graph of the slope, you can see it's not very negative at the start. But then by the time we get into the middle of that section here, we're seeing a very negative slope. And so it's just getting further into that negative direction. All right, next graph. And again, as I look at it, I'm always starting by looking to see where are the zeros. So at each of those points on my graph over here, I should see it having a value of 0 because the slope is 0 there. Now, based on that information alone, which graph is the derivative? It is B. Because that's the only one that has those as the zeros. We didn't have to dig any deeper into, okay, where is it positive, where is it negative? Next graph. Now in this graph, there's really only one 0 that we can actually take a look at, and that's going to be of much help to us here. It looks like we got a 0 somewhere right down in here. So we know we should be crossing 0 around 4. Well, actually that's going to make it pretty easy for us, right? Because as I take a look at those graphs as options over there, I only see one of those that's really a good possibility for that. But there's something else I want you to see on this one, because it's going to help you probably also with conceptualizing what we're really graphing here. Because I want you to take a look through the section to the left of that 0. So as I'm taking a look down this portion of the graph right through here, notice that the graph isn't changing a whole lot in its steepness. It's almost a line through there. And if it's a line, that means that the slope is not changing. So because this is almost a line, that means that when I go and take a look at the graph of the derivative, I should see something that's almost flat. I should be seeing something where I'm showing that the slope is basically not changing. And so you end up with something that's a fairly horizontal slope. Now, it wasn't perfectly straight, which is why this isn't perfectly straight either, but it's pretty darn close. So we should have zeros wherever our graph is leveling out. That means our derivative is going to be 0, so I should have one here between -5 and -6. That alone is enough to tell us which one the answer is. It was A. Now, of course, if that wasn't enough to go on, then you could also go and check and see, okay, where was it 0 around 0? But we don't need to, since we already had that one. And it was the only one with a 0 around the right spot. Next graph, please repeat the thought process. All right, so I'm looking to see, okay, where is the derivative going to be 0? And it looks like I got two different points where it should be 0. One of them is around -6-ish. And the other one is around between 3 and 4, somewhere between 3 and 4. Well, already we can see that it must be graph B just for that reason, because you notice these other ones, they tried to insert an extra 0 in here. But that's not going to have a slope of 0 at 0. Notice our slope at 0 is some sort of negative number in there. So yes, the answer is B. Something else to notice about this one, just helping to conceptualize what it is that we're working with in here. So you notice that between those two zeros that we identified earlier, all along this stretch, my graph is changing a little bit, but not a lot, right? At least in terms of the slope. It's not straight, but it's not super curved either. It's pretty close to a line. And I want you to notice then how that ends up showing up as we actually do the derivative graph. Notice through here it's showing that our slope is not changing a lot. It's changing a little bit, which is why it's not horizontal through here, but it's not changing a lot. It's not changing very quickly. If it were changing really quickly, that's where we end up with something that's much more extreme in terms of the curve of that derivative graph. Two more of these to do. So with this one of the things that can make it a little bit trickier is that if we just go by where the zeros are, we end up seeing between, -4 to 5-ish, somewhere in there, we should have a 0. We should have one at 0-ish. And we should have one that's about 5. It looks like, actually, only one of them meets all those requirements, right? And that is why, yes, it is B. And again, though, if you're feeling a little bit stumped because you might have looked up at A and said, well, this one looks kind of close, maybe that is the one that I'm looking for, just because it can be hard to read from a distance at times. You could have also answered the question by saying, okay, is the slope positive or negative between them? So for instance, if I take a look at this section of the graph, is the slope of my graph there positive or negative? It's positive. And so that means that on the similar section of my graph over here on my derivative, I should be graphing positive numbers. And you notice in graph B, it's graphing positive numbers there, showing that our slope is positive throughout that whole section. Whereas the other one shows negative. All right, last of these matching type of problems. Please figure out which one of those is f prime of x, our derivative. All right, and for this one, again, if we look to see where our slope's going to be 0, we got 3 of them. Let's see here, -4. And so we can see where we are expecting to see the zeros based on our original graph. So for the derivative of f of x, I'd say that the graph up there that actually matches that would be A. So now in this problem, we're going to be kind of taking a similar view of it, but in this case, I'm giving you 5 different points, 5 different values that I'd like you to please put in ascending order. So from smallest to biggest, please order all 5 of those. So in order to answer this problem, I want to actually go through and take a look and see what are each of those slopes relative to each other at least. And so, like f prime of a, remember that means the slope at point A. So I'm just going to sketch that in roughly there with a line so I can kind of see about where that would be. All right, f prime of b. It's going about through like that. That's nice and straight through there. F prime of c. Just touching the graph. And f prime of 5. So in that case, it's not labeled with an actual letter, but we got to go up to where 5 is and figure out what's the slope when x is 5. And so those are our 4 slopes. Now notice the last one, 0. Notice it does not say f of 0, it does not say f prime of 0, it just is the number 0. So I now need to put these in order from biggest or from smallest to biggest. Which one should be smallest then? Well, notice the slope at A is positive. The slope at B is negative. And the slope at C and at 5, those are also positive. Only one of the numbers is negative. And so that means that f prime of B must be the smallest because it is the only negative number of the whole bunch. So f prime of b, yes, is your smallest there. Now, the other 3 derivatives here, those were all positive numbers, right? So then what has to be after our only negative? Yeah, 0. So the next one in our list is going to be 0. And then we have our 3 slopes. So I've dealt with this, and I've dealt with this. Now, of the 3 slopes that remain, I need to figure out which one is biggest and which one is smallest. Well, we're talking slopes here. A bigger slope looks what? What does it look like when we look at the graph? Steeper. Yeah, it's steeper. And so if I'm going from smallest to biggest here, I want the least steep slope next. Well, the next least steep slope is going to be at f prime of what? 5. And then, so now I've dealt with that one. So now it's between A and C. Which one looks steeper, A or C? I'd say A looks steeper there. So A must be the highest one. So then it's next up going to be f prime of C, ending with f prime of A, which is our steepest slope of all. And so then we put those derivatives in that kind of an order. And so you notice that as we're doing these, really what we're doing is we're just trying to train our brain now to start looking at these things in terms of slopes of the tangents at each of these points, because it really does take time and take experience to really see this and understand it in terms of those slopes. So you have this graph on paper, and we're now going to sketch what is the graph of the derivative going to look like. Now for that, again, I can still start with the same thing I was starting at when I was matching them. And that is, start by figuring out where's the 0 going to be. Now, where is the derivative going to be 0 on this graph? It is going to be at 0, yes, because notice that's where the graph levels out. Now that means that when I go and make the graph, I can put a point there at 0, 0. Because when x was 0, that's when our slope was 0. All right, now a little bit of generalization now. What about what's happening to the left of that 0? Is our slope going to be positive or negative?
Negative.
Negative. And so that tells me that as I go to the left of that first point of my derivative, it's going to be heading down and to the left, but I don't know exactly how yet. So take a look at what we're dealing with there, and notice it's not very negative at the start. But then it's getting to be a steeper negative as we go along. And so it kind of looks like we're going to be doing maybe one of those. And so it looks at first when we're doing these like we're looking at a curve down there, because this is a curve, right? But let's actually look at some specifics, because I want you to actually see that in action. This is where I want you to break out your ruler. Please estimate what does the slope appear to be when x is -1. And so when finding the slope of that derivative at -1, that's how I would sketch in the derivative line, that is the tangent line to the curve, and that's what I'm using the ruler for. And so I'm looking for the slope of that line. When we find the slope of that line, what is it? So yeah, I'm going to call that slope a -1/2. So that means that when x was -1, my slope was a -1/2. So I can go ahead and plot that point right there. Why don't you please do the same thing for x equals 1 now? What's the slope when x equals 1? All right, so when I sketch in my tangent line, this is what I'm looking at. And based on my sketch, I'm looking at a slope of 1/2 again. And then we see the slope, we're going up 2/1, which means our slope, is not 1/2, our slope is 2. Which is a mistake I made on this left side as well. That was also a -2. See, mistakes do happen. Now, having done those, that still doesn't tell me what the shape of the graph is between those points. So I'd like you to please find two other points, two other slopes. Please find the slope here at -0.5 and up here at a +0.5. And so here I've visualized the tangent at x equals 0.5. And again, I can look and see, okay, as I go between any 2 points there, how far am I going up, how far am I going over to find my slope? And notice in this case, it looks like I'm basically going up 1 and over 1. So the slope that I'm going to get then at x equals 0.5 is 1. So that means that when x is 0.5, my derivative is 1. And so when x is -0.5, what do you suppose the derivative is? Well, this graph is symmetrical. It's a -0.5. So is this actually going to be that kind of a curve that we were anticipating? No, it's actually straight. Because although this is curving over here, it's changing our slope at a regular rate, at a linear rate as it turns out. So to draw the graph in, just draw the line in that goes between those points. Now in this case, I got very specific because this was the first one we were doing this way, and so I really was wanting to find the very specific numbers that it was going through. For some of these next ones, I'm not going to be quite as specific because I'm just going to be focusing on building some of those instincts and helping us to see what is happening with them. So for our next graph, you notice it does look very similar to the one we just did, but of course it is different. And so you remember the problems that we were doing before, those matching type problems. The first thing we did was we found where the derivative was 0. Same thing on this one. Where is the derivative going to be 0? All right, so this does have 3 different zeros for our derivative. We have one up here, one down here, and one up here. So I know that when I go and make the graph of this, I should have a crossing 0 in those 3 places, because remember, I'm graphing slope down here for the derivative. That's what derivative means. It means slope. All right, so I know those 3 points. Now again, I said I was going to do this one much more generally. So I'm not going to worry about the specific slope here. I could draw it in and calculate it, but I'm not going to worry about that right now because that's not our biggest priority. I did that on the last one because I wanted you to see why it was a line and not a curve. So on this one, between these first sets of zeros, so right in this section here, Our original graph has a slope that is what? Positive or negative? Negative. And you notice I say it has to be positive or negative. I know it can't be both because it's not crossing through 0 between them. I'm looking between the zeros. And so yes, it is negative between them, which means that when I go and draw my graph down here, it's all going to be existing somewhere down here in the negatives. Now the question is exactly what should that shape look like? Well, we can actually just kind of figure it out roughly by thinking about the slope in the middle here. That's where it's steepest, right? In this case, that means the most negative. So I'm just going to put a point down here. Remember, I'm not saying that it actually is perhaps -1. It might be. I'm not measuring that. I'm just roughing this in to see what it looks like. And so then we can see that a good way to sketch in that slope, I can just do that. Because I know that it's going to be at its steepest right in the middle there in this particular example. Okay, so what's happening between 0 and 2? Basically on the positive side, the right side of the axis, our slope is positive, right? Which means that our points should also be showing all positive slopes. And what we're showing here by that curve is that the slope is just a little bit steeper here in the middle than it is out towards the zeros, which would make sense. Because of course, it's not like it's jumping straight from a slope of 0 up to a slope of 1 or something like that. That would give us those piecewise functions like we were seeing in our last lesson. Alright, so for this one, again I want to start by finding those zeros, but this one can be a little bit extra tricky because the nature of this graph, just the way that it strikes us at first, we really want to try to grab these 3 points as zeros. But those aren't the zeros we're looking for. Because remember, the zeros of the derivative are where the slope is 0. So it's actually this one and this one. So the 2 points where it's going to be 0 are about here and about here. Those are the only zeros. Now between those 2 zeros, is the slope positive or negative? It's negative. And so I know that I'm going to be between those, going down and then back up again. Now to the left of our first 0 and to the right of our second 0, notice in both those cases our slope is positive. So I know it's going to continue up on both sides of those 2 zeros. The question is though, is it going to continue going up steeper and steeper like, or is it going to be kind of leveling off as it goes outward? And for that, my question to you would be, what's happening with this slope? As I continue with this slope, it's getting steeper and steeper, right? And in fact, it's getting so steep, it just keeps getting positive, and it gets more and more positive. It doesn't like stop going positive. And so it actually ends up doing one of these. If we were to actually make a perfect graph of this, by the way, which we aren't worrying about doing right now, but if we did, you would actually end up with a perfect parabola. So that's basically what we've ended up sketching is a parabola for this one. Alright, for graphing this one, I've already sketched in the tangent of the very far right point there. And so you can see that it's not super steep, right? It's positive, but fairly shallow. So it's not going to be a super big number out here. So I'm just going to sketch in, I got some point out here. It's not very big. And remember, we aren't being precise about this. We're just kind of sketching in what this looks like so we can see how these relate to each other. All right, now I just want you to start thinking for a moment here. If I kept going to the right, what would happen to this tangent line? Would it be getting steeper, or would this tangent line be getting flatter? Yep, you notice it's still, the graph itself would still be going up, but it'd be flattening out more and more, so that the slope of the tangent line would get more and more shallow. And so, do you think that this graph would ever hit the point where the graph actually hit 0? Where the derivative actually hit 0, that is? It doesn't seem like it. I mean, it gets really close to 0, but it doesn't seem like it's actually going to hit a point where it actually gets totally flat, at least as far as we can tell, because this is looking like a square root graph to me, and I can say, okay, well, that's probably just going to keep going up then. And so this graph actually has no zeros in it to be plotted. All right, and then continue to look at my graph from there. If I go over to the left, it looks like at that point my slope is about 1. Okay, so it's getting a little bit steeper. So like back here at this, so it's probably like 1-ish, something like that. And so it's gotten a little bit steeper there. What happens as we get really close to -1 though? Notice my tangent line's getting a lot steeper, right? And in fact, it keeps getting steeper and steeper as we approach -1. So I know my graph is going to be getting really steep. Okay, so I can go ahead and kind of sketch in what's happening there. And there we go. So as we keep getting closer and closer to that -1, my graph slope, that is my derivative, is getting steeper and steeper. What actually happens though at -1? It's like it's approaching vertical. It's getting really close to vertical at least. So when we see our graph of our derivative, what do you think is happening at -1? I'm thinking there's an asymptote there. Now, did you need to figure that out yourself looking at this graph? No, this is one of those bonus items where we can then see, okay, if we take this even further, we can see that this is actually approaching an asymptote there at -1. So there is at least the rough sketch of our graph of our derivative.